Constructors. We all heard about constructors earlier. So what the constructors will do, they will initialize the data members of your class. For a given object, the data member will be initialized. So if you remember, I told constructor is nothing but a simple function or a special type of function of the given class which performs initialization of every object. Right? Initialization of object means what? Initializing constructor will be called automatically by the compiler whenever a object is created. The moment we declare the object in the main, for example, I have a class called as complex and I declare an object C1. The moment I declare the object, the constructor will be called and its data member will be initialized at compile time. Right? By creation of the object means what? Whatever memory is required by that object, that memory will be allocated for this object. The task of occupying that memory with some values will be done by whom? Will be done by the constructor. When the constructor will assign values to the data members, then that memory will be occupied. Right? Okay. Constructors initialize value to the object members after storage is allocated to the object. Yeah, the same thing. Now, once the object is created, the storage is allocated, and then the constructor will add values to that storage. Right. Example, we have a constructor of class A, a default constructor, whatever object initialization is to be done. So X will be initialized with 0 over here. Right. Normal example of a constructor. What are the characteristics of the constructor? So number one, constructor should always be declared in the public section under the public access specifier. Why it is important? Because once the object is created from the main, the constructor should get called. And the constructor is similar to any public function, right? It is a special type of function, but ultimately it is a function, right? So that is why if it is not public, how can the function be invoked? Right? That is why all the constructors should be public in the given class. Now they should have the same name as that class. We already know it, and they do not have any return type, not even void. Right? All the constructors will have no return type, and it automatically gets invoked. That means it automatically gets called whenever objects are created. Now they cannot be inherited, right? If I have a situation of inheritance where I have a class A and I am inheriting class A into my class B, right? I like something like this I am writing. That means if there is a constructor in class A, like every public function or protected function gets inherited, we cannot inherit uh, the class, the constructor of any class into the derived class. No. But there are certain data members of the class A which are going to be initialized by class A only. Right? Class B's constructor cannot initialize them. So what happens is, in such a case, when we create the object for any class B, say suppose B1, we create the object for derived class, then the constructor of class B is going to get called. From here itself, the constructor of class A is called. Okay, so what it says, constructors cannot be inherited, though derived class can call the base class constructor. That is what we saw just now. Now, how it happens, we'll come to that when we see inheritance in detail, right?
Sir, so
Yeah.
always it's the case. So whenever we declare a constructor for a derived class,
Hmm.
whenever we like write the default constructor, it will uh,
Yes.
always run
Yes.
the class A constructor.
Yes.
Okay.
I'll tell you why. Simply because the data members are private. Okay. And who can initialize the data members? The constructor. That class constructor only can access the data members, not class B constructor. Hmm? That is
Yes,
why
sir.
it has to get called. Okay. Fine. So any ordinary function can have default arguments. The constructor too can have default arguments. Now what is meant by default arguments? Suppose I have a class A constructor. I can initialize X with 0 here itself. So that if this is a parameterized constructor example. So if I create an object A1 like this, the constructor will get called, and if I am not passing anything, then automatically X will be initialized with 0. But if I have passed something, uh, let me call it I, because again the data member will be the same. If I have passed something, then X will be initialized with that value of I. Suppose I am passing 10, right? So default arguments, the concept of default argument as it works with normal functions, the same way it works for constructors. Okay. You cannot refer to that to the address of the constructor. Okay. We cannot refer to the address of constructor. And lastly, constructors cannot be virtual. Now, what is meant by virtual? Virtual is a keyword that we use when we define a function, right? A normal function that has no body, right? If in a given class there is a virtual function, then that class is considered to be an abstract class. Okay, we'll see that in third unit when we see virtual functions in detail. But any normal function can be a virtual function, but constructors cannot be virtual in nature, right? Remember this thing. Whereas we can have, there's a concept that we are going to see of destructors. So we can have virtual destructors. Definitely we can have them. So I told you all there are three types of constructors. Definitely the first one is default constructor. That means A, suppose the class name is A, having no arguments. Then the parameterized constructor will be the constructor which is accepting a few arguments, maybe of any type. I can have those many constructors, parameterized constructors. If I am having a different configuration of these parameters, I can have those many constructors. For example, a parameterized constructor in my class A can be accepting two integer values, whereas there can be a parameterized constructor in the same class which is going to accept only one integer value. Now suppose if there were two data members x and y, x is initialized with I and y is initialized with j. So in this case, x would be initialized with I. What about y? It can be also initialized with I, right? It can be so. Fine. So we can have n number of constructors. And if you observe this is nothing but constructor overloading. Remember function overloading?
Yes.
What was the theme? Same function name, but different set of arguments. Same is followed by constructors. Same, since they are constructors, their name will be obviously same because they belong to the same class, right? So their names are same, but the list of arguments is different. And depending upon the list, the right version will get called. Suppose if I'm creating an object A1 directly, then the default constructor will be called. If I'm creating an object A2 in this way, then this constructor will get called. And if I'm creating an object A3 by passing two values, then this one will get called, right? Then there is a concept of copy constructors. Now, what is meant by copy constructor? I have to create a copy. Okay, so here what I do, I create a fourth object. I'll write over here A. A1 is one object, A2 is another object, and I create A3 to be the copy of A2. For example, what I'm doing, I'm creating the object A3, which is copy of A2. So I have to pass A2 as an argument, right? Why I have to pass A2? Because, for example, look here, if A3 was to be initialized, I mean the data members of A3 were to be initialized with 3 and 4, I passed 3 and 4. But I want the data members should be initialized with A2, then I have to pass A2, right? Because I want to create A3 as a copy of A2. Got it? So a copy constructor should be created. So I have A, which is my constructor name. Now what is being passed? A2. What is the type of A2? A. Again, I have to name it. A2 should have a local name, right? So I'm calling it O, or I will call it obj, object, which is being sent. I have to copy A2's contents, right? That is why I have to refer it. I have to add a ampersand over here so that obj is not a new object which carries the same values of A2, but obj is a reference to the A2, right? And then if I use the same reference, I'll say obj.x, obj.y. That means whose x and y are these? Indirectly, they are x and y of A2. Now, how do I want to utilize a and y of A2 to initialize x and y of A3? So I write here x equals to obj.x, y equals to obj.y. Clear? Remember this scenario, this one. Whatever I passed, I utilize that in order to initialize x and y. Similarly, whatever is being passed over here, I'm utilizing that object to initialize x and y. For which object? For creation of A3 object. So this sort of constructor is called a copy constructor because it is copying x and y value. So I'll go by the conventional way. This is my memory, and like any other object, A2 was created with its own x and y. A2's x and A2's y. Okay. What value it had? What value we had passed to A2? Since it was created in
3.
the default way, let us no. See this declaration. A2 was created in the default way. Okay. So what should be the value for x and y? See, I would have written it over here. 0, Generally, in the default constructor, we initialize all the data member with 0 value. Okay. So let us consider A2, A2's X is having 0 and A2's Y is having 0. Hmm? Now, if I similarly, A3 was to be created. Okay, A3 was to be created. Now, when I only mention in the argument list a obj, that means a new object is created. That object is having name as obj and it's having its own data members, which are again initialized with 0 and 0. Understood? Why they are initialized with 0? Not because it is a new object which is declared, but the object that we are passing is a2 and that gets assigned to obj, right? It's a copy of a2. So x of a2 will be assigned to x of obj. Y of a2 will be assigned to y of obj. Got it? Okay. Now, with this copy constructor call that I have made over here, do I want to initialize the data members of A3 with OBJ, or do I want to initialize data members of A3 with A2? What do you think?
A2.
A2, right? If I write here directly OBJ and I mention obj.x and obj.y, what I have done over here, that means I'm copying this x value to A3's x and OBJ's y value to A3's y, which I don't want. I want A2's value to be assigned. Understood? So by adding an, look here, by adding a ampersand, I am not creating an object, but I am creating a reference to that object. Which object? The object which was passed from your A2 object. So this object will never be created in the memory. On the contrary, a reference will be created which will carry the address of A2 object. Understood. Now if I say obj.x and obj.y, that means obj is pointing toward A2. So A2's indirectly, A2's x will be assigned to A3's x and A2's y will be assigned to A3's y. Got the significance? If we don't write any of the constructors, at least the default constructor will be created by the compiler, this one. The compiler will automatically create it for us. But if we define any of the constructors, like if I don't define the default constructor, but I define the parameterized constructor, this one or this one, then the default constructor will not be created by the compiler. So I am allowed to create an object A1 passing two parameters, but I am not allowed to create an object without any parameter. No, it will give error. Understood? In which case, if I am having a parameterized constructor. Got it?